Good morning students. Today we are going to discuss few important topic from chapter 3 current electricity. Now the first topic which we are going to discuss is your relation between EMF and terminal potential difference. Now already we have discussed what is cell, what is EMF and what is internal resistance of a cell. Now let me try to find out the difference between EMF and terminal potential difference of a cell. So cell is basically denoted by the electrodes and the internal resistance. So you see in the figure the dotted square or the dotted rectangle encloses positive and negative terminal with a small resistance small r. So this combination is your cell. Now you see in the cell we have connected a source. For example, you can connect a voltmeter across the cell. Now the reading that comes out in the voltmeter when the circuit is open means when the key is open, is nothing but the EMF of the cell. Now when we close the key, what will happen? Current will flow from the cell or energy will flow from the cell, and as a result, if you connect a voltmeter across the cell, which we have shown here across the dotted rectangle, the value of the voltmeter gives you the terminal potential difference. So you can say that when no energy is drawn from the cell, then the terminal potential difference across the cell or the reading shown by the voltmeter connected across the cell is nothing but the EMF. But once we connect this cell in a circuit, so energy starts flowing from the circuit. So if you connect a voltmeter across that cell, the reading that comes out in the voltmeter is nothing but the terminal potential difference. So you can say the maximum value of terminal potential difference is nothing but the EMF. And when you connect a cell across the in a circuit, what will happen? Basically the energy keeps on moving from the cell to the circuit. So at any instant, if you connect a voltmeter across the cell, you will get terminal potential difference. So EMF is always greater than the terminal potential difference. So you see two circuits we have drawn. One is key is open, another one is key is closed. Now when key K is closed, then the reading or the equation which we can write is nothing but is your V equal to IR. So you see V is the voltage that gives in by the voltmeter, and I is the current, so the expression is your V equal to IR. Now when key K is open, so what will happen? You see, try to understand the equation. Key is open, you can say that when key is open, no current is flowing, is not it? So how the equation 2 is possible? But practically here we have written the equation by assuming that we have just connected the key or just closed the key. So at the very beginning, it is nothing but the EMF or the maximum terminal potential difference. So under that condition, you can say that capital R, that is external resistance, and the internal resistance small r is nothing but is in series, because if you consider the terminal, positive terminal is connected to capital R and negative terminal is connected to small r. So definitely it is not in parallel. So if it is not in parallel, then it is in series. So in parallel, basically what happened? The sources are common, no? Means if you consider two resistance, both end of the resistors must with the positive terminal and both end of the resistor must with the negative terminal. But here you see one resistor capital R is connected with the positive terminal and smaller resistor is connected with the negative terminal. So you can say it is not in parallel, rather it is in series. So if you consider the key K is open under the condition you have just connected the key at the very beginning. So the equation will be your E equal to capital I small r plus capital R. So if you expand I small r plus I capital R, so I capital R is your capital V and I small r is already there. So I small r equal to E minus V. So small r you can calculate E minus V by capital I. So in place of I you can use equation 1, that is your V by R. So V will be down and capital R will be R. Capital R will be up. So if you simplify, small r equal to E by V minus 1 capital R. So you can calculate small r by knowing capital E, capital V and capital R. So small r is the internal resistance of a cell. So this expression is very important. Expression number 2, expression the final expression R small r equal to E by V minus 1 bracket capital R. Capital R is your external resistance. So in our next topic we are going to use this expression. So you can say that small ir equal capital I small r equal to E minus V. So you can say EMF is always greater than terminal potential difference because capital E is equal to I small r plus V. So EMF is greater than the terminal potential difference from the mathematics point of view, and also practical point of view also EMF is your maximum potential difference, you can say. Now next topic we are going to discuss is your combination of cells. So two combination we are going to discuss. One is your series, another one is your parallel. So this expression we are going to use expression number 2, simplified expression number 2, that is your V equal to E minus IR. So here two cells are connected in series. First cell has an EMF E1 and internal resistance R1. We have not shown the internal resistance part. You can show, it's up to you. And second one is E2 and small r2. Now current I is flowing. It's from the positive terminal, obviously. So potential difference across AB will be here E1 minus IR1. We have used this expression equation 1. Equation 2, basically simplified equation 2, that is E equal to I small r plus V. So V equal to E minus IR. So IR1, R1 is your internal resistance, and VBC is your E2 equal minus IR2. So if you consider the system as a combination, so VAC equal to E is your equivalent EMF and minus I small r is your equivalent internal resistance. So also you can write VAB equal to VA minus VB, higher potential minus lower potential, because A is with the positive terminal, and VBC is your VB minus VC. So if you sum up V minus VB plus B goes up, you will get VA minus VC. So VAB we are substituting E1 minus IR1 plus VBC is your E2 minus IR2. So VA minus VC is nothing but is your VAC. So VAC already we have defined E minus IR. So we have simplified E1 E2 bracket minus I within bracket small r1 plus small r2. So if you compare, you will get E equal to E1 plus E2 and R equal to R1 plus R2. So net EMF is nothing but the sum of the individual EMF of the cell, and net internal resistance is equal to the sum of the internal resistance of the cell. So in series, the net EMF is only the addition of the EMF of the individual cell, and net internal resistance is nothing but the sum of the internal resistance of the cell. So next is your parallel. So here in parallel, two cells, one is your E1 and another one is your E2, and internal resistance R1, another internal resistance R2. So source is there, so current I is flowing from the source, and the potential across the source is your V. So as it is parallel, so terminal potential difference is common. So I splits up into I1 and I2. So E1 equal to I1 R1 plus V, E2 equal to I2 R2 plus V. So total current is here equal to I equal to I1 plus I2. So I1, let me substitute E1 minus V by R1, and I2 E2 minus V by R2. So E1 by R1 plus E2 by R2 minus 1 by R1 plus 1 by R2 V. So E1 R2 plus E2 R1, R1 R2, simplified R2 plus R1 by R1 R2 V. So R1 plus R2 by R1 R2, you have to take common. So if you take common, then I within bracket, because basically R2 plus R1 by R1 R2, we have taken this term and we have divided throughout the equation. So what you will get, I R1 R2, R1 plus R2, and E2 E1 R2 plus E2 R1 R2, then this R1 R2 goes off minus V. So again we are using this equation E minus V IR. So IR equal to E minus V. So if you compare internal resistance, equivalent internal resistance is nothing but is your R1 R2 by R1 plus R2 in case of cells connected in parallel, and equivalent EMF is your E1 R2 plus E2 R1 by R1 plus R2, that is your equivalent EMF. So these expressions are simple once you understand. So please go through this topic and try to understand. So if you have any doubt, please put your doubt. But before going to winding up this class, please download this class at the very day of your class. Otherwise, due to technical problem, it may get lost. So don't keep the videos later on to download. Okay, so please download at the very beginning of your class. So thank you. This is all about